Hello and welcome to a new video about programming. Okay, I hope you can learn something from these videos. Okay, so I'll try to make this video more educative, like in a way that will help you more to learn. Okay, so welcome. I don't know if I should show my camera, but right now I'm using something else. I'm using this study stream session, but no problem. I will close this streaming session. Right here, closed, so I couldn't be available for you guys. Okay, let's see if this works. Oh, that's not what I meant. Okay, so let's see. Oh, cam. Here we go, but it's too dark. Too dark to see. Now that's better, I guess. Okay, we will take that. That's what we have. Okay, let's work with what we have, right? So logo is on top. We're ready. Okay. So I will be basically limiting myself to teach you or to upload the content related to C and C++. Why? Well, because I discovered that for me, efficient languages are important. When I say efficient languages, I mean two things. One is that it runs fast, and the other is that it doesn't use a lot of memory. So it has efficient memory usage. And C and C++ are the ones that I've chosen for that, because those are good in those two categories. I like a bit of Java and Kotlin, so JVM languages as well. The speed of them is okay. The problem is that they use too much memory. And learning that, some will argue, and I am one of those, that it makes you sloppy in terms of memory usage. Because it uses too much memory. It's like having a dog that drinks too much water. So that's kind of inefficient, right? So instead, what I think is better is a language that uses less memory. Having said that, Java and Kotlin are great for other things, for, probably Android development, because that's the thing that they are used for, and that. But when you go to higher performance code, then it's not worth it, I would say, because of memory usage. Okay, so I can show you. Let's go together and find what kind of programming languages we have. Okay, so programming languages chart by speed or something. So I want to clarify something for you. I will help you choosing programming language even if it's not C or C++. So go to images. I think this one is a good chart. Is this one a good chart? No, this is new, but I think this should be like the time, right? It takes to run. Then you have C and C++ being very fast. Ada, ATS, I haven't heard a lot about them, so probably they are more a niche category. Have Java 7, Go, Scala, Lisp, C Sharp, Haskell, Pascal, Fortran, Clojure. Okay, Python is quite slow. Probably this is the number in bold, the number that's most important. So the median. Python is 40 times slower than C. That's too much for my taste, for me. Um, Sorry, I think I have like stopped using like stop showing my camera. Is that right? Probably it's yeah, it's here. Yeah, I mean, just for a minute I will stop using it, but I'm here with you guys. Okay, so yeah, for me Python is too slow. Okay, then if we go here, I would say from I don't know about Rocket, but from Closure onwards, uh, it seems to be a more decent performance, right? But again, I don't know. I don't use Closure, but probably some will say Closure is fine. The problem, I think it's a JVM language Closure, right? The problem is the memory usage. We're gonna see that a bit later, but now, just in terms of raw performance, I would say, well, from here and above would be acceptable for me, right? But in terms of actual memory usage, Go would be the winner. In terms of simplicity, memory usage, performance, I would say Go would be the winner, right? So probably, if you're new to programming, I will encourage you to learn Go and C or something like that. If you want to be a programmer that creates fast programs, so that's may not be the majority of programmers, because majority of programmers uh, are involved in web development. And that's not very fast. I mean, the web is slow, right? Okay, so I'm in some crackers, right? So sorry for that. This is my breakfast. Um, so yeah, that's good, interesting. So C, C++, and Go. Well, Java is fast, but it uses too much memory. So I would say C, C++, or Go. And C++ includes C. So you can do C style C++ if you like the simplicity of C, which is what I kind of lean towards. Or you can do Go. I don't know about Go. I haven't programmed a lot in Go. Almost nothing. I would say I know nothing about Go, other than it's faster than Java and uses less memory than Java. Um, I would actually choose Java if it was even slower than what it is, but it used less if it used less memory, you know. So here we have something that I want to show you. So here at the chart of the left, we have the energy used by each programming language. And we have C, Rust, C++, Ada, Java. Java is good in terms of memory usage, but here we have a Go down here. So it seems to be using too much energy. I mean, again, I don't know, but we will have to investigate more on how much memory Go uses, right? Now in time, here we can see that Go is 2.83 what C is. So Go, I would say, is good. Yeah. Now Python is too slow, Perl, Ruby. You know, some people like to use those languages. I mean, lots of people. JavaScript even is a lot faster in Python, but yeah. But I would say C# is a Microsoft thing. I don't really use lots of Microsoft products or other than GitHub. So Camel, Pascal. So Go, C++, C, and Rust if you want. But I heard that Rust is just a bit too much complicated. But yeah, it's there. And here in megabytes, which is the amount of memory it uses, Go is great, even better than C. But I will say it's the same, but because there's too little difference. But then to Rust, and this is kind of fine. From here to the top, there's decent fast languages. all this from Rust to Pascal. But if you go down here, you will see what I'm talking about. Java, 6 times as much memory. And I can say that's true because I was making a program the other day and Java, Kotlin Java, JVM programs, and it used like 300 megabytes. And I say, why 300 megabytes? Some will say, well, that's not a lot. Well, it is because it's a simple program. So I made the same program, a very, very similar program in C++. I mean, using libraries and so on, and optimizing both for memory. And the C++ used 11 megabytes. Java used between 250 and 300 and something. So let's be generous. Let's say it uses 250, right? And my C++ code used 11 megabytes. That's at least 10 times less in memory. And here it is. It says it's using 6 times more. Yeah, I mean it's the case actually. That's the case. So too much. I mean, I will maybe pay for, I don't know, two times, 3 times, but not even 3 times. I would pay for 2 times as, I mean, I would pay from C# and above in memory. Right, but that's too much, even too much, because these are slow. Yeah, I mean, Haskell, how fast is Haskell? That's not that fast. You see right here. It's not that slow either. I mean, that's not that bad. And then you have Haskell, Lisp. Well, I encourage you to do 2 things. If you're like me, you're like an engineer, like someone that wants to write fast things. Do C style C++ and Go. That's it. That's my recommendation, okay? So I'm starting with C++. Maybe later I will learn Go and teach it to you. And maybe I will learn and I will record how I learn Go, because that's fun as well. But for now, it would be C++ and C. So let's compare C++ with Go, which we mainly here use C and C++ interchangeably. But okay, in terms of time, here we have some advantage of C++ in relation to Go, which is, let's say, half, twice as fast. C++ twice as fast as Go, which is great. And it's not that much, but it is quite a number. In terms of energy, Go uses too much energy. I don't know, energy used of Go versus C++. I don't know if someone have written something like this. Here we have. I'm opening lots and lots and lots and lots of pages, websites right here. I should show my face, right? So how can I move this? Can I move this towards here? Yes. So sorry, I'm here. I'm back. Hey, now we can make these more personal, so you will be able to see me. So ranking languages, programming languages by energy efficiency. I think this is the same chart we saw. For some reason, I think that. No, it's not. Haven't found anything. So which programming language uses the least electricity? I mean, here you can see that Go and C++ are not that far away. That's what this is not, this is, yeah, this is joules, right? Why here it says megabytes? It's a comparison between joules and megabytes. So I would say Go is not that high, which is kind of cool. But, here we can have that. But here, 3 to 1.34. Oh. Is faster, greener, the browser of compiled languages, blah blah blah. So that's good. I mean, every page cites that document, that chart. I like to see some other source of research, right? What the hell? Okay. Golang, C programming, C++, C, Go, C++, application, community. Yeah, C++ is faster than Go. Yeah. So another thing is to code in C or C++, but in a way, the face is not really visible here. That better? Okay. Another thing also important to do is to have a clean mind or a clean style of coding, right? So imagine you develop a clean style and you're able to cleanly code in C++ or C in a simple way, minimal way, in a good way, testable way, and so on. Then you will get great programs at great speed. That's what I would say. Yeah. So in embedded applications, Go uses more memory, but not that much more. It's not bad. Not bad. Go is not bad. I would say you won't be wasting your time learning Go. Yeah. Go, C, C++. Higher level language, procedural, use mainly backend web development, use mainly web development, systems development, pro small single feature, contains every feature under the sun. Yeah, it's kind of messy, C++. I'm not a big fan of C++. I think C++ is great, but I want to use C++ in a minimal way. That's what I want to do. If possible, use C-style C++ when possible. Yeah, I mean, love that programmer. C++ is not. Wow. Faster compile time. Goes faster compile time. Higher salaries. Okay. Better performance C++, more versatile. Learn both. What about learning both? I mean, best of both worlds, right? Okay. Great. So let's now move this back here. Okay, I'm learning how to use my computer. Great. Okay, so this is main.c, which is the older brother of C++, right? It's a very simple programming language, but very powerful as well. It's like, it's like a screwdriver or a knife. It's a tool that allows you, that it's a simple tool that allows you, can help you in all projects you have. So it's like a raw tool, something like that. I would say that about C. Okay, so here you have a file, of course, because we write text, and that text later becomes programs, right? and this is a text editor or code editor in an IDE, integrated development environment. This is Qt Creator, but I was experimenting with other IDEs as well. Let me see if I can show you those. So, let's see. Oh, Kdevelop is one. I'm experimenting with this. CodeLight, I'm also experimenting with this. And I think that's it. I mean, Kdevelop, CodeLight, and Qt Creator is that it. I guess. Oh, I don't know if this is showing all the apps that I have installed, but I don't think it's showing all the apps. But yeah, CodeLight's one, Kdevelop's another, and Qt Creator is another, which is the one that I'm using right now, right? It is good. You will find. I mean, you will from those you will. I mean, see what you think is better. That's fine. I would say that's up to you to choose what IDE. Those are the ones that I would recommend. I run in Linux. I'm running Debian, so working fine in Debian. Some are better than others in some things. You have to test to see that. But right now I'm using Qt Creator. Okay, so here we write a program, right? As you may find, this program is structured in functions, right? Like this. Now there are like two types of functions. You can see this is one type, which has the parenthesis nothing and the parenthesis. And then we have this other type of function. We have something in parentheses. These are called parameters, right? Which are information to tell the function how to run. That's it. So here we start from the bottom to the top in C, unless you take the time to do some name duplication declaration to move it the other way around. But like the natural way of doing this is starting from the bottom to the top. Okay, so we start from here. So when we run the program, the first thing is it will run this function. Then we'll start, for example, running these lines right here. Okay. So why do I have sorry? Why do I have this fix stdout function? So why do you have that? Is stdout broken? Yeah. Well, not really, but yeah. Well, the default behavior of stdout is to it was kind of optimized for lots of data printing as opposed to printing when you tell it to print. And I prefer to print it to make it print when I tell it to print, right? Rather than being able to print like more data but not in the right time. I prefer to print slightly less data or print slightly slower, but when I say print, it should print. So that's what it says, and here is the description, the implementation of that function. So fix, for me this is a fix, right? Because sometimes what's happening is that I was printing some things to the standard output and it was not getting printed. So I say, what the hell is going on here? Then I find out that it's because it's set to print when a buffer is filled, which is not at all what I want. I mean, I think this is a bad decision of the language designers. I mean, the way I'm using should be the default way, because printing when you want to print should be the default way. I mean, as easy as that. And if you want more performance, then you can say, well, print when this buffer fails. So we can make the buffer larger and print, reduce the number of system calls or whatever they do. And that's so. Here, it says that it will print in a buffer, but it will be line buffered. So when I print a new line, it will just print it there. Won't wait for any buffer to be filled at all. Okay. Sometimes when I used to write simple programs, I didn't have this problem. But then I was writing more programs and doing this and that, more things right here and there, and it stopped printing. So I'd say, what the hell? What's not printing? I'm telling to print. Then you start becoming crazy. Where's my bug? You know? I mean, so yeah, I mean, if you don't know in your head all the documentation about the design choices of the language, even though this language is kind of simple, but yeah. So, and the way, by the way, the printing thing is something. There's a feature of C added to make it friendly to people, right? But it's a thing you include. But the language is very stable and very easy to understand without, if we exclude the printing part of it, right? I mean, with this, I'm trying to say that not the rest of the core language doesn't have these kind of problems, right? That's what I'm trying to say. The printing part does. And for me, this is the way I found that solves it and works for me. And that's kind of cool. So, okay. So now we'll compile this, which in Qt Creator you do with Control B. And then, as you can see here, it's compiled. And it should say, hello world. So let's comment these things just to help you understand how this works. So I'm running now. And it says, hello world, right? And this, I guess, this crash thing is because I'm using like GTK3 or something, right? I think so. So it says hello world, and that's it. This is what we want. When we want, it gets printed, right? Just kind of cool. Maybe what I should do also is create a function called init. And inside here I will call fix stdout. I mean, why would I do that? Well, because maybe there's more fixes I have to do to the language, right? And yeah, sets up the language and the program, if that's a way of saying it, to fit my good taste. Okay, this is what this init function does. Okay, then here we have some other things which we will run right now to see what happens. And it shows 9 screens. If you want to know more about this program, I showed it in the previous video, right? But it uses the GTK3 graphics library to do this. So it shows a graphic library instead of just showing that on the screen. Why would I do that? Because sometimes I need more than one screen output, right? So if you only have one terminal, then the output will be mixed, like everything, like mixing all these numbers, and that's not really useful because sometimes I need to separate those. Those are from different things inside the program. So one can be, for example, error reporting. The other could be like non-error reporting. There could be like messages received from, a peer, and that can be like a feature A, feature B, feature C, So this is the way I found to do this. So we can also see how much memory all this is using. This is the program. It's called Clean Software, and it uses only 32 megabytes. Yeah, and that's not a lot considering it's using the graphics, showing the graphics app. That's great. So if you want to know how to do this, well, let's find out, right? So we're just calling Memalog and then program. Well, this is not really being used, I guess. Well, this is my way of allocating memory so that later I can free all in one call to avoid memory leaks. But I have to enhance this more to free maybe the types of memory that I want or something. This is just a better way of automating memory management that it's not fully developed yet, but you know. And here free all. So when we end, we free everything so that we don't owe anything to anyone. And here program, it says main GUI. Breeds program started to the terminal, as you can see right here, and then starts main GUI, which shows the GUI. And here we have the screens, like screen 1, 2, 3, input commands, X, Y, A, B, Z, which is what you can see right here, 1, 2, 3, input commands, X, Y, A, B, Z. So input commands allow me to write something here. Well, the other docs also allow me to write, which is kind of weird, but yeah. So I'm not an expert in this, but yeah, so this creates the titles of the screens, then it creates a grid of screens, and as I said, I have already shown this, and if you want to have fun watching me coding and making mistakes, you can go watch the previous video, and that would be kind of cool. Yeah, sometimes I like to do this, and then it will separate it again, so not the problem really. Okay. So this is how it works. 9 titles, 3 columns, 3 rows, total sections. Yeah, I mean, if you see, you can, we can do an optimization here because and titles would be the same as total sections, right? And oh yeah, but it's not meant to be that way. Okay, so we don't really need this. So we have, I mean, right now the way it works, we have to make sure the columns and the rows are the ones that will fit this, right? This and these titles right here. I mean, and then end titles. Let's see, we can go to where it's being used. Let's see if it's being used. It's not used at all, so we don't need this. That's better, right? And then total sections is being used, and we can see if this is being used or not. And it's not being used again, which is kind of strange. All right. Okay, so let's see if it compiles and doesn't give us any errors. Yeah, it's compiled in 3 seconds, which can be reduced with some CMake lists to probably 1 second or something. But yeah, so columns and rows are indeed being used here and here, it's easy to see. And rows are being used here. And yeah, so we have optimized the program a bit, reduced the code size, which is great, always great to reduce the code size, right? And then, well, what it says, it's create a new window, the big window, sets the size, 800 pixels by 600 pixels, I guess is this width and height. And then it connects to this, so it knows when to quit. I guess this connects it to the X button. I think that I was doing some of this in the previous video. And create new grid container, add it to the window, right? to this window, right? Defined via JTK container as a parameter, then that's the grid. Okay, then here this for loop, this nested for loops populate rows and populate columns, right? Yeah, I would say that's okay, and it just populates that. Here's a box. I don't know what this means. Hexband, backspan. I don't know what that is. It attaches the box with the corresponding columns, column and row, like ID, let's say. And it shows the label, which is titles count, which is this, and allows us to scroll the window, and that's that. Yeah. So and yeah, so and if the count is different than 3, we make it update every 1000 milliseconds, which is every 1 second, to show new data, as you can probably see. So it's been a while, so go here, go down, so every second shows new data, right? Shows the cumulative number of lines printed by the old program, but that's kind of just a thing to test it, right? And this, the fourth, so count 3, which is the fourth, is with start count from 0, right? We set it to be editable, so edit text, so we can write here and send commands to the program. Yeah. So that's basically how it works, and it shows it and calls GTK main, which I don't really know what it's for, so no idea. So this is how this works, and every update text view, if you remember this here, it's passing a function which is update text view, which is this right here. It is this is the count that has been shown on the data outputted to the to all the grid members, right? And yeah, so this, we have the text view, then we have the line. It says it prints line and the count plus plus, so it increments the count, and yeah, that's what it does. Lots of things of this that I don't understand, and with this GTK3, because I haven't done really any GUI programming in C. So yeah, this is new. First time using GTK3. And yeah, I need to learn more about this, but yeah, that's basically it. And then we also have a CMake list.txt, which is a file that allows us to tell the program how to compile our program, right? Tell the ID how to compile, say the compiler and use the compiler and this and that and so on. So this is Project Clean Software, language is C. It uses the package config and GTK3. Alright, GTK3, whatever, definition, that's the only thing it uses, really. And yeah, that's basically it. So I think this should not be here, because we are already defining all the files that end with .c right here, so it's redundant. Alright. Sometimes the IDE does things for you that you don't want it to do, but yeah, it's not that smart. But yeah, it's kind of semi-smart. So yeah, let's run it again. As you can see, here we have line whatever, and keeps incrementing by 9, kinda. So yes, that's it. That's basically how this works. I should move this a bit for next video probably, because yeah. Okay. So 2 instances. So I should have 2 programs right here. This is the one, and this is the, well, that's not, this is the other. So I have 2 programs right there, as you can see, running in parallel, 2 instances of my program. Because the program is really just a file. It gets loaded twice and run twice. Can we do that? Like opening 2 pictures or 2 instances of a website or whatever. So we close. It says process program finished and whatever it says, process crashed, whatever. No. So this is how you code in C, in the most simple, elegant language there is. It's a bit too verbose in some regard, but yeah, it's fine. Has its use. But again, Go is an evolved version of this, which is a bit less fast, it's a bit slower, but nicer and more modern. So yeah, I'll learn both C, C++, and Go. But don't learn that many features of C++. Learn minimal C++ and Go. And minimal C++ is kinda C, right? Oh, go first learn C, then learn C++ a bit, and then learn Go. Or learn C, Go, and then C++. But start with C, right? So that's it. I would say, I guess we have been recording for a while, right? That's 42 minutes. I would say that's enough for now. So thank you very much for watching this video. Have a great day. See you in the next one. I hope to upload videos more frequently, but yeah, just for fun, for sharing with you, whatever I have in my mind at the moment I'm recording, right? So thanks. Bye bye.